Good morning, everyone. My name is Michael Armis, and this is my presentation on the fate of lactate for kin 516. So today we're going to be talking a little about the liver and its function in exercise. One of the cool things we're going to talk about is, so inside the cytoplasm of the liver and muscle cells, it contains glycogen granules and these really high functioning enzymes for glycogen synthesis and glycogen breakdown. So during a normal conditions, for example, following a meal, glucose does not accumulate in the blood. It enters pathways of energy, metabolism. It stores as glycogen or converts to fat when there's too much of it in the bloodstream. So an example of like exercise where there's high cellular activity, the glucose that's available actually oxidizes through the glycolytic pathway, through the citric acid cycle and the respiratory chain to form ATP, which is what we need when we're exercising. And an example of when we're not doing much, when there's low cellular activity, the glycogen reserves actually inactivate key enzymes, key glycolytic enzymes, and the end result is surplus glucose to form glycogen. Okay, so glycogenolysis, basically that explains the cleavage of glucose from a glycogen molecule. So this causes whatever is left of glucose to react with a phosphate ion and to produce glucose 6-phosphate by passing the first step of the glycolytic pathway that we talked about the last time. And so when this happens, glycogen actually provides a glucose molecule for glycolysis, and there's a net gain of 3 ATP that occurs rather than 2 ATP during the glucose breakdown. So one of the most important enzymes that's involved in this is glycogen phosphorylase. So that actually becomes inactive following a meal, and glycogen synthase activity actually increases to facilitate storage of glucose obtained from food. So essentially, in between meals, when glycogen reserves decrease, right, because we're moving around, we're going on with our day, liver phosphorylase becomes active, and at the same time, depression of glycogen synthase activity actually goes down. And this happens in order to maintain stability in blood glucose for use by body tissues, right? So we're talking everything from your muscles to your active organs to whatever, right? So the body still requires this. One of the things I kind of want to talk about is, according to McArdle, skeletal muscle at rest actually shows higher synthase activity, where during physical activity, it actually increases phosphorylase activity with a commitment button of the synthase. So here's glycolysis. This is the diagram we were talking about the last time in our last lecture. And when we were discussing glycolysis before, we were actually discussing coming from one molecule of glucose and the end product being 2-pyruvate and ending up with lactate. But in this lecture, we're going to be talking about when we come from glycogen and bypassing that first phase, going straight into glucose 6-phosphate and essentially ending up with that 2-pyruvate and discussing what the liver actually does with that pyruvate to help us keep exercising. So in the previous diagram of glycolysis, we were looking at the 2-pyruvate and whether that forms into lactate, or if that can actually be processed and go down into the Krebs cycle. But what I kind of want to talk about is lactic acid and what is lactic acid versus what is lactate, right? So according to McArdle, lactic acid is actually, it's formed during exercise, primarily anaerobic glycolysis. And lactic acid is what essentially forms all those hydrogen atoms. Whereas lactate is formed from those hydrogen atoms, and that hydrogen atoms actually bind with potassium and sodium, Na+. The cool thing about lactate is it doesn't accumulate. So its production actually equals its clearance when it's being created in the body. So when sufficient oxygen becomes available during recovery, when you're doing intense exercise and you're taking that little breather, or it's active recovery, those NADs that we were looking at in glycolysis actually scavenge for the hydrogen atoms that are attached to the lactate to form ATP through oxidation. Then after that, the skeletons of the pyruvate molecules that we were looking at the end product of glycolysis, those are reformed from lactate during activity, and that forms one pyruvate molecule and then two hydrogen atoms from a molecule of lactate. So those become either oxidized for energy or synthesized to glucose during gluconeogenesis in the muscle that's working during the Cori cycle, which involves the liver. Another cool thing about lactate is that it's a valuable source of energy. So it's produced during intense physical activities such as anaerobic glycolysis, but like if you really want to break it down, maybe just like repeated sprints or just like basketball going back and forth down the court with no real rest time. But one of the things about adaptations that we look at with certain athletes, endurance athletes actually have a higher rate of clearance when it comes to their production of lactate. Now, that being said, too, on the other side of the spectrum, power athletes also have adaptations as well that help them with that lactate clearance. So when we're looking at certain adaptations from exercise, athletes or people who have a bigger content of type 2 fibers, power athletes, actually have the ability to convert lactate into pyruvate at a higher rate. So that kind of takes into consideration as to how you want to train. So if you're a power athlete, you could actually convert that lactate into pyruvate faster, and you can send that pyruvate into Krebs cycles so that you can create more ATP, and that's another training adaptation that you can have to be able to withstand intense exercise for longer periods of time. So one of the things I wanted to talk about before we start talking about the Cori cycle is this process of lactate shuttling. So the lactate shuttling, this idea, it enables glycogenolysis in one cell to supply other cells with fuel for oxidation. So the muscle thus is, it's a major site of lactate production, but it's a primary tissue for lactate removal and oxidation. So when we're looking at the muscle that's working or while we're exercising, the glucose that's in the blood, it's basically used in the muscle to create ATP through glycolysis. And through this process, lactate is created as a byproduct, and then it's carried into the blood, and then it's taken to the liver for gluconeogenesis. So how exactly does this happen? So when we're working anaerobically, when there's no oxygen available, intensity is super intense, or exercise is super intense, through anaerobic metabolism, we're trying to create ATP for muscle contraction so that we can still keep exercising at that exact intensity. So when this happens, the muscles are converting pyruvate, the end product of glycolysis, into lactate through the enzyme lactate dehydrogenase. This reaction is super important because we need it to happen so that we can maintain levels of NAD, which is needed for glycolysis to actually occur. So the lactate that's created, or when there's excess amounts of lactate that's produced in the muscles, it's taken up by the liver where gluconeogenesis occurs. So then the lactate is converted back into pyruvate, and then through that process, it's converted back into glucose, taken away from the bloodstream and back to the working muscle so that further glycolysis can occur while we're exercising. So when we were discussing exercising and working out at certain intensities, some of the factors that cause us to stop exercising is when we're not necessarily ready for the demands of that exercise, but maybe physiologically we haven't created those adaptations yet. So when we're exercising and we're trying to go as hard as we can and we're going sprint after sprint, there's obviously going to be increased lactate levels because glycolysis is going on. If there's increased lactate levels, we know that the acidity is going to increase, causing a decrease in pH levels, right? And then we're not going to be able to create as much ATP as we need for that exercise to continue. So what happens is that there's actually deactivation of enzymes necessary in that energy transfer that we were looking at earlier. And basically the muscle contractile properties are affected. We're no longer able to keep moving, and that's what causes us to slow down, and we're huffing and puffing, and we're no longer able to keep exercising. So through the Cori cycle, we're able to shuttle out lactate, convert it back into glucose so that the muscles can keep working at that intensity that we desire to keep training at. And that's just one way that the liver helps us in regulation of that process. My name is Michael Armas. This has been my presentation on the fate of lactate. Thank you so much and have a good day.